We're going to walk through one question from the WileyPLUS practice assignment this week. This is from Chapter 7, Section 1, Exercise 13. Skittles are a popular fruity candy with 5 different flavors, colored green, orange, purple, red, and yellow. A sample of 55 people recorded their favorite flavor, and the results are shown in the table below. Perform a chi-square test, as indicated in the steps below, to see whether or not the flavors are equally popular. This is an algorithm-based question, so every time you access this question, you're going to get a different set of numbers in this table. Let's look at part A. State the null hypothesis. This is going to be a chi-square goodness of fit test because we have one categorical variable, favorite flavor, and that variable has more than 2 mutually exclusive levels. Our null hypothesis is that in the population, the proportion of people who like each of these 5 is equal. So the proportion for green, which is P sub I, equals the proportion for orange, equals the proportion for purple, the proportion for red, and the proportion for yellow. All of these proportions need to equal 1.00. Because they're equal, 1.00 divided by 5 groups would give us 0.2. In other words, the null hypothesis is that in the population, all 5 groups will be P equals 0.2. In part B, if every flavor of Skittle were equally popular, how many people in a sample of 55 would we expect to choose each? Our expected value is N times P sub I. In this case, part A, we said that all P sub I equals 0.2. N, which is 55, times P sub I, which is 0.2, gives us 11. Part C, how many degrees of freedom do we have? Degrees of freedom are equal to k minus 1, where k is the number of groups. In this case, we have 5 different groups: green, orange, purple, red, and yellow. 5 minus 1 gives us 4 degrees of freedom. Part D, calculate the chi-square test statistic and the p-value. I'm going to do this using Minitab Express. We need the data from our table, and in Minitab Express, we can just enter favorite color, green, orange, purple, red, and yellow, and the frequency, which was 15, 7, 13, 11, and 9. I'll go to statistics. The chi-square goodness of fit test is going to be under tables, and I'm using a Mac, but I believe this is the same on a PC. Chi-square goodness of fit. We need to change this to summarized data, because what we have from table 1 was summarized data. Our observed counts are in column 2, the frequencies, and our category names were in column 1. The default is to test equal proportions, which is what we have in this case. Recall our null hypothesis was that all proportions were equal. We click OK, and this gives us our chi-square test statistic of 3.64. We'll go back to part D. Chi-square equals 3.64. Our p-value was 0.4574. In part E, what is our conclusion? Our p-value is greater than 0.05, so we fail to reject the null hypothesis. That limits us to options 1 and 3. When we fail to reject the null hypothesis, that means that there is not evidence in favor of the alternative. So there is not evidence that the proportions are different, or that any of the proportions are different. This is the first option. We did not find evidence that the assumed proportions are not correct. We submit our answer, and hopefully we scroll through and see that everything was correct, which it is. As always, if you have any questions as you're working through these WileyPLUS problems, please post them to the discussion board on Canvas.